All right, number 20. The figure below shows the graphs of the function, the first derivative, and the second derivative, and we have to identify each curve. Okay, so what I'm looking for here is, you can kind of look at the picture and kind of tell, which one's linear, which one's quadratic, which one's cubic. So that should kind of tell you the answer right away. But they won't always be that obvious, and you're not going to be just looking at that one part. Like, for example, if we did not include the left-hand side of the graph, it would be a lot harder to do. So let's talk about some tricks of why we know that. First of all, we're looking for maxes and mins on a function. Maxes and mins on a function are going to be places where the slope of that function is actually 0. So right here, if I look at this graph, I'm looking at a clear curve right here, and I'm thinking, okay, well, that's got to be a horizontal tangent, and this has to be a horizontal tangent, and this has to be a horizontal tangent. So the derivative of this graph is going to have zeros here. Okay, so 2 of those occur on the same curve. They occur on this middle curve right here. Okay, so let's kind of identify which other graph has zeros where this graph has slopes of 0. So right here, this graph has a 0, and right here, this graph has a 0. And as we can see, that's this one curve right here. And the crazy thing is, this one curve has its own 0 right here, which goes with a 0 on this function. So what tells me about that is this one that has 2 has to be the highest order. The one that has zeros where the first one has max and mins has to be its derivative. So this one has to be f of x. This one right here. The derivative of that, let's use the highlighter, is going to be this one right here, which is going to be f prime of x. And then the derivative of f prime of x is actually going to be right here, because it has a 0, and so that has to be f double prime of x. All right, next question. Find the equation of the tangent line tangent to the function at x equals 3. You are going to have one of these questions. You have to be able to do it. So we need the slope, which is actually y prime, and we need a point, of which we have the x coordinate, and that is 3. The point is easy to get. Find the y coordinate by plugging 3 into the function in both locations. So that's going to be 3 times 9 minus 10 times 3 plus 5. 3 times 9 is 27 minus 30. That's negative 3 plus 5. That's 2. So that's our point, 3, 2. Now we have to find our slope. We're going to take the derivative of this equation. So the derivative of 3x squared is 6x. Derivative of negative 10x is negative 10. The 5 goes away. Now we're going to plug in 3 at x equals 3. Right here, that's 18 minus 10. So I believe that leaves us with a slope that is 8. 18 minus 10. So put it all together in the great form y minus y1, so that would be 2, equals m, that's 8, x minus x1, and that would be 3. Feel free to go ahead and solve that if you want to for y. Not required. You can leave this answer as is. Number 23, equation of a line normal to a function. Okay, so normal to a function, once again, still a line, so we still need the slope, and we still need a point, of which we have this x value. The only deal with the slope is it's going to be like the negative reciprocal of the slope, of the derivative of y prime at x equals pi. Because if we found the slope or the derivative at x equals pi, that would be the tangent line, and a tangent line is actually perpendicular to the normal line. So that's why we take the negative reciprocal of that slope. Okay, so let me go ahead and get the y coordinate of the point. I'm going to plug pi in here, right? We've got cosine of 5 pi at that point in time. 5 pi is not a number right on the number line, but if you think about it, if we go around, we start at 0, we go back, we have 2 pi, we go again, we have 4 pi, 5 pi is going to end us up over here. So hopefully you know that the cosine over there is -1. That's our trig. Okay, so we've got our point. Now we need the slope. So we do need to take the derivative. So y prime will equal, well, this is the chain rule. It's the cosine of blob. The derivative of the cosine of blob is negative the sine of blob times the derivative of blob. Derivative of 5x is 5. So y prime is actually equal to -5 sine of 5x. Okay, find this at x equals pi. And if you plug pi right into here, sine of any kind of pi, 1 pi, 2 pi, 3 pi, whatever pi, is always going to be 0. So this means y prime is actually equal to 0. And that's the negative reciprocal of 0, because that would be the slope of the tangent line. So if I take the negative reciprocal of this, it becomes undefined. Because if I flip 0 over any number, it becomes a number over 0, which is undefined. You should remember that undefined lines are actually vertical lines. They have no slope, and it needs to go through the point pi comma -1. So if you kind of think about this on a graph, if we had, here's 1, 2, 3, here's pi, a little bit more, -1, a vertical line going through here, they're all actually going to have that same x value. So the equation for this line is actually x equals pi. All of the points on this line have the same x value. All right, 23. Find the minimum value of xy. This is a really confusing way to write this problem. They literally want you to take x and multiply it by y, which in our case is x times 4x minus 3. It was really badly worded. And minimum value, they literally, like they're saying, they really want a minimum point. So here's our function. Our function is x times y. If I want to find the minimum point on a function, I'm going to need to take that function's derivative. Now, you're welcome to multiply this out first. That probably will make it easier. Otherwise, we'll need a product rule. So it's 4x squared minus 3x. And the derivative of that would be 8x minus 3. Set that equal to 0. So we're going to add 3. So x is 3 over 8. That's where we think the minimum will occur. Let's just check that it is in fact a minimum. 3 over 8. I'm going to plug a number to the left and the right into the derivative f prime of x. So I'm going to plug in like 0. If I plug in 0, I get negative. If I plug in 1, I get positive. So this is in fact a minimum. They actually want the minimum value. So that means whenever we use the word value, we are asking about the y. That's really what we want to know. So we just take our 3/8, plug it up here into the y equation. So y is equal to 4 times 3/8 minus 3. Honestly, if you left it like this in a free response, you'd probably be getting all of your credit. I'm going to cancel out the 4 and the 8, make this a 2 and a 1. So I've got, basically, it's a lot easier to see here now. 3 halves minus 3, that's 1.5 minus 3. That's a negative 3 halves, or basically negative 1.5.